3D yazıcılarda kullanılan hammaddeler. 3D yazıcılar hammaddeyi eriterek katmanları üst üste yığarak, katmanlı imalat teknolojisinden faydalanıp 3 boyutlu gerçek bir nesne oluşturuyor. Bu işlemde kullanılan hammaddelere filament denilmektedir. PLA, ABS, PVA, katkılı PLA filamentler. Ahşap, bakır, bronz, bambu. Naylon, pet, sıvı reçine. PLA, polilaktik asit mısır nişastası bazlı bir çeşit biyoplastiktir. Günümüzde sıkça tercih edilmesinin sebebi sağlığa herhangi bir zararının bulunmamasıdır. Geri dönüşümle gübre olarak da kullanılabilmektedir. İdeal işleme sıcaklığı olarak 180 ile 200 derece arası tavsiye edilmektedir. PLA malzeme kullandığınız zaman eflatundan deniz mavisine kadar geniş bir renk seçeneğiniz bulunmaktadır.
PLA stands for polylactic. Should be described.
ABS, akrilonitril butadiyen stren petrol bazlı bir plastiktir. Sıtmalı platforma ihtiyaç duyan ABS baskı oldukça sağlamdır. ABS'nin ideal baskı sıcaklığı 250 ile 260 derece olup mat bir görünüme sahiptir. PLA gibi sıkça kullanılmaktadır.
ABS filament. For a more refined look, acrylic paint can be applied to ABS. If you won't be 3D printing for a while, make sure to unload your spool of ABS filament and put it in a bag. This filament absorbs water from the air and of 3D printing filament. Air.
PLA baskı esnasında havada basılamayan nesneler için destek denilen yapılar oluşturulmaktadır. Polivinil alkol sıvıda çözünme özelliğiyle günümüzde mevcut olan en iyi destek materyallerinden biridir. Sıcak veya soğuk suya atılıp çözünerek parçanızın desteklerden kurtulmasına yardımcı olur.
This model is printed using Ultimaker PVA and PLA in dual extrusion. Let's take a closer look at how PVA works with Ultimaker 3. PVA is a support material that dissolves in water. It's printed using dual extrusion on the Ultimaker 3. It is ideal for printing complex geometries that require support for large overhangs, deep internal cavities, and intricate structures. With PVA support material, models like this gyro can be printed in place without any post-printing assembly. Traditional methods won't allow for this kind of production. Cura automatically identifies which part of your model requires PVA support. PVA fully supports the print, right from the bottom of the model to the narrowest cavities. With its great thermal stability, Ultimaker PVA is more resistant to degradation, which guarantees a better print quality for longer periods of time. Once the print is finished, simply place it in water to dissolve the PVA. You won't need any harmful chemicals as the material completely dissolves in tap water alone. The PVA is also completely biodegradable. Once the PVA has dissolved, rinse the model and let it air dry before doing any additional post-processing. The Ultimaker 3 can print PVA in dual extrusion with both PLA and nylon. This means you can create complex, aesthetically appealing models with PLA and durable, functional prototypes with an engineering material like nylon. PVA support enables.
When it comes to printing intricate parts, removing support material can become an impossible task. For these situations, using PVA can create incredible parts that take little to no effort to clean up. Polyvinyl alcohol, or PVA for short, is a polymer that is soluble in water, making for easy cleanup of heavily supported models. Some things to keep in mind about PVA are that it is a more expensive material, it's only compatible with filaments in the same temperature range, and using it can increase the overall print time. It's also very important that the filament be fully dehydrated before printing.
Katkılı PLA filamentler. Ahşap. Gerçek bir ahşap görünümü ve kokusu katmak için ahşap filament iyi bir seçimdir. Diğer termoplastik filamentler gibi ahşap filament de benzer bir baskı sürecinden geçer. Gerekli işleme ısısı 175 ile 250 derece arasında değişir ve baskı hızı 20 mm/saattir. Bakır, bronz, bambu. %30 karışımlı yapısıyla gerçek bir bakır veya bronza dokunulmuş gibi bir izlenim bırakır. Bu baskı yöntemi imal edilecek parçalara doku olarak farklı bir değer katar.
Fantastic-looking metal prints. Copper fill and bronze fill are metal powder particles mixed with PLA to bring you prints that look like they were casted. The new metal filaments print excellent in all the open source 3D printers we offer in the Adafruit shop. Temperatures for printing are the same as PLA with no heated bed required. Printing at high resolutions of 100 microns works great and is recommended for making models easier to polish. Be sure to take care when priming the nozzle, as the filament can maintain its heat because it's, well, metal. We're happy to say that it prints excellent on both Bowden and direct drive extruders with no modifications required. We printed these 3D scans using 230C with 2 shells. If your print is more delicate, you might want to bump up the shells to 3 or 4, but as you'll soon see, stringy bits are very easy to clean up. Of course, prints with no islands like these selfie busts will print without too much cleanup. Fresh off the build plate, these prints look more like clay than anything metal. The stringy bits are super easy to remove. You can simply use your fingers to rub off any bits and smooth out the prints. A hobby knife can be used to speed up the process. If your prints look super stringy, don't fear. Remember that the tumbler will smooth out a lot of the outer shell of the print. Even this super stringy dragon looks great after a bit of cleanup. Copper fill is pretty strong as seen in these bend tests. It took quite a bit of pressure to break our Raspberry Pi case and actually took quite a bit of force to bend back before it snapped into 2. Next up, it's time to really bring out the metal shine with a small tumbler. This small 3-pound tumbler from Lower Tone supports prints that are about 90 millimeters tall by 85 millimeters wide. For the medium, we'll be using brass metal screws. Use different size screws so that they can smooth out smaller details in the prints. Here we're using double zeros, number 2s, 4s, and 10 size screws. Obviously, don't use bigger screws for smaller prints. After you have your screw sizes ready, carefully place the print inside of the barrel and begin tumbling. Just make sure not to over-tighten the lid. Remember that smaller prints can take about 6 hours to look really shiny, while larger objects with a lot of detail can take up to 36 hours of tumbling to get a very polished look. Avoid getting dust on your hands by being sure to use gloves to remove your prints after it's tumbled, as the screws grind together and create metal particles. You'll definitely want to periodically check on your print to make sure it's still in one piece. Here the Dragon didn't make it all in one piece, but it's easy to glue back together later. Use a small brush to clean off the metal dust from the screws grinding. Finish it off by using a shop towel to clean and polish off the remaining dust into the print. And after about a day and a half of tumbling, this selfie bust looks like it was casted. The screws really do an excellent job of smoothing out the layers while bringing out the metal shine. Other methods like steel wool or sandpaper really bring out PLA's chalky white color, totally ruining the polished look. And so there you have it, that's copper fill from ColorFab. We carry copper fill and bronze fill in the Adafruit shop. We think it's awesome for artwork, jewelry, cases, and of course,
making things with wood usually requires a couple of tools for cutting. Cut wrong and you might have to start all over again. This is bamboo filament. It's made with a mixture of bamboo wood and PLA. Parts are sturdy, like a block of wood. It feels and smells just like real wood. It's great for electronic enclosures, sculptures, and of course, cosplay props. Bamboo filament works just like regular PLA, so no heated bed is required. Although you can use heat to make the parts stick to the bed. While printing, you can even change the color of the filament by switching between higher and lower temperatures. Print speeds of 50 mm per second work pretty well for most parts, and it's safe to use with direct drives and even Bowden systems. Use slower or no retractions to avoid the gears from grinding the filament. Cleanup is very simple. Leftover bits from retraction are easy to pull off with your bare hands. They shouldn't be sharp, just be careful not to get any splinters. Smooth out the remaining edges using a flat metal putty. Trim off any small hair artifacts using a flush diagonal cutter. It's safe to clean up any blobs left behind, as they'll be sanded away and stained later. Make sure to check your gears before printing additional parts. You want to make sure that the gear teeth don't have any sawdust clogged in it. Now let's take a look at post-processing. We'll finish off the parts by applying a stain. It's real wood, so we can use regular old wood stains to finish off the parts. First, we'll start off by sanding down all the parts using 230 grit sandpaper. Make sure to sand down all the small spaces. You can apply your stain patterns with different colors or even layer them on top using a multi-layer stain. We'll start off with a dark walnut for the first layer. Stir and use a cloth to apply a textured stroke on the blade that'll really give it that wood grain pattern. Don't apply a lot of pressure, just gently glide the cloth across the blade. Fold the cloth into a small shape and then apply 1 or 2 strokes to the crossguard and then both sides of the blade. Let it dry for about 5 minutes and then use an 80 grit sandpaper to remove any blotches. This will also help you get that weathered look. After applying a second coat of red oak color, we'll sand that down again and then apply a small amount of green. Once applied, quickly wipe it off. This will give it that hint of green in the wood. And then to finish it off, we'll switch back to 230 grit sandpaper. And just like real wood, you can use fillers to plug in any gaps. Wood putty worked great for filling in some of the gaps on the top part of the blade tip. Make sure to apply it after you're done staining, and then let it dry and then sand off any leftovers. And that's it. You can keep applying multiple layers until you're happy with it. You can really see the difference when compared to an unfinished part. It's definitely worth the effort to post-process. And that's
Naylon. Naylon filament oldukça dayanıklı ve güçlü yapısıyla daha çok medikal alanda sıkça kullanılır. En çok kullanılan filamentlere nilon 618 ve nilon 615 örnek verilebilir. PET. PET kristalimsi ve renksiz bir hammaddedir. Isıtıldığında ve soğutulduğunda saydamlığı değişir. PET gibi modifikasyona uğramış versiyonu da mevcuttur. Baskı işlem sıcaklığı 160 ile 170 derece önerilmektedir.
TG is a great medium between PLA and ABS with a few other special properties. PETG usually prints around 230C, falling right between PLA's 215C printing temp and ABS's 250C. It has a similar density to PLA, but is not as hard as ABS, so it can be more susceptible to scratches. PETG has some of the best layer adhesion properties as well. This means that parts will overall be more durable, however removing supports can be more difficult. PETG is more chemically resistant, so unlike ABS, it cannot be vapor smooth, but because of its superior layer adhesion and higher transition temperature, it can survive more intense post-processing than PLA.
Sıvı reçine. Özellikle stereolitograf adı verilen bir 3D baskı tekniğinde sıvı reçineler kullanılmaktadır. Ayrıntı konusunda üst düzey bir kalite sunmasına rağmen maliyeti yüksektir. Sıvı reçine kuyumculuk, mimarlık ve dişçilik sektörlerinde sıkça kullanılmaktadır.
By balancing liquid, light, and air, 3D printing technology is getting smoother and faster. The new process is called Continuous Liquid Interface Production, or CLIP for short. Other printers put down one solid layer at a time in a lengthy mechanical process. CLIP works by projecting a series of ultraviolet images through a special window located below a bath of liquid resin. The light causes the resin to harden into the projected shape, like a series of solidifying movie frames. As the printed object is lifted out of the bath, fresh resin is pulled toward the window. 3D printing is now a continuous process, and the speed is mainly limited by how fast the resin cures and its viscosity.
İşte yazıcıların avantajları ve dezavantajları. İşte yazıcıların avantajları. Bilgisayar destekli tasarım ile hazırlanan ürün modeli saatler hatta dakikalar içerisinde tasarlanan nesneler oluşturulabilir. Geleneksel yöntemlerle üretim yapılırken ihtiyaç duyulan makine, teçhizat ve işçilik maliyetleri azalır. Birçok işi ortadan kaldırır. Karmaşık yüzey geometrisi olan nesneler kolayca nesnelere dönüştürülebilir. Kullanılan sarf malzemesi filamentlerin temini hem kolaydır hem de uygun fiyattadır. Birçok sarf malzemesi biyoplastik olduğu için sağlığı olumsuz etkileyecek özelliği yoktur. Ergitirken çevreye zehirli gazları çıkarmazlar. Ayrıca doğada çözülebilme özellikleri vardır. Geleneksel yöntemlere göre maliyeti oldukça düşüktür. Mühendislik eğitiminde tasarım çalışmalarında kullanılabilmektedir. İşte yazıcıların dezavantajları. Diğer seri üretim yöntemlerine göre 3D yazıcıların üretim süresi daha uzun bir üretim yöntemidir. Diğer üretim yöntemlerinde gereken kalıp, takım tasarım gibi aşamaların 3D yazıcılarda olmaması nedeniyle toplamda daha hızlı ürün gerçekleştirilebilmektir. Sadece üretim süresini için 3D yazıcılar seri üretimde diğer tekniklere göre daha yavaştır. Yüzey pürüzlülüğü, en profesyonel makinelerden en amatör kendin yap makinelere kadar bütün 3D yazıcılarda yüzey pürüzlülüğü bir problemdir. Katmanlar çok küçük bile olsa dikkatli bakıldığında gözlemlenebilir. Malzeme sınırlılığı, son teknolojik gelişmelerle birlikte malzeme seçenekleri oldukça artmış olsa da, geleneksel üretim yöntemleri ile karşılaştırıldığında malzeme çeşitliliği oldukça azdır. Döküm ve talaşlı imalat ile karşılaştırıldığında hassasiyet oldukça büyük bir problem olarak karşımıza geliyor. Ebatlar, 3D yazıcı tekniği ile dev makine parçaları üretmek oldukça problemlidir. Hacim büyüdükçe yukarıda bahsedilen problemler katlanarak artıyor. Eklemeli imalat teknolojilerinin uygulama alanları. 3D baskı, otomotiv, havacılık, medikal, eğitim, gıda, film ve eğlence sektörlerinde kullanım alanı her geçen gün genişleyen bir imalat teknolojisidir. Eklemeli imalat teknolojileri ilk önceleri birçok sektörde görsel bir doğrulama aracı olarak kullanılıyordu. Otomotiv endüstrisinde de parçaların prototiplerinin üretilmesiyle sınırlı olan teknoloji daha çok görsel analizler ve kalite kontrol amacıyla kullanılmaktaydı. Şüphe yazıcı kullanılarak üretilen urbe aracından sonra otomotiv sektöründe eklemeli imalat ile araçlarda kullanılabilecek fonksiyonel sonucun parçaların üretilebileceği fikri oluşmaya başlamıştır. Ev tipi 3B yazıcıların kullanılması ile fabrikalarda maliyetlerin ve tedarik süresinin düşürülebileceği ve aynı zamanda pres ve büyük şekillendirme makinelerinin kapladığı hacmin azaltılması ve üretim hattının sadeleştirilebileceği öngörülmektedir. Havacılık endüstrisinde de 3B baskı teknolojilerinden, özellikle operasyon zamanlarının azaltılmasında, üretim maliyetlerinin düşürülmesinde ve hava araçlarının imalatında kullanılan parçaların ağırlıklarının azaltılmasında faydalanılmaktadır. Aynı zamanda 3B baskı yüksek teknoloji gerektiren hava araçlarının parçalarını üretme ve tamir etme yeterliliği olmayan ülkelerin kısa zamanda düşük maliyetle bu kabiliyete sahip olmalarında önemli bir fırsat olarak görülmektedir.
And the hangar here is XB-1, history's first independently developed supersonic jet, and it's the 1/3 scale prototype for Overture, which is our 65-seat supersonic airliner, which will be the first mainstream supersonic airliner.
Revolutionizing high-speed traveling, and they are the first one to do real
engineering, which means the ability to go design something in 3D on your computer, test it, optimize it through simulation, but also to be able to realize it quickly in real 3D form through 3D printing.
We use our Stratasys 3D printers to create functional prototypes in order to do fit checks or gauges while we're building the vehicle. We use them for drill blocks, as well as using the machines to print flight hardware that's actually going to fly away on the XB1 demonstrator.
So this is XB1 supersonic demonstrator. Compared to Overture, this is 70 feet long. Overture's going to be 210 feet long. So smaller airplane, but it's got all the technology you need for mainstream supersonic flight. And our designers, using in-house 3D printers from Stratasys, were able to go see how the designs were working, iterate faster, and ultimately come up with parts that are better designed, that are more lightweight, for less time and less money that would have taken otherwise.
The way they are approaching the development cuts years from the development phase and also at the manufacturing stage.
So we have built hundreds of 3D printed drilling fixtures, jigs, other kinds of build and assembly tools to make XB1.
This drill guide is used for drilling holes in our aft fuselage. Using the Stratasys F900 on this particular drill block saved us about $3,700, and it also saved us a significant amount of time. So instead of taking weeks for us to get a CNC 5-axis machined aluminum component in-house, from a design to part in hand, it only took us a couple of days.
We deliberately keep the printers very close to the manufacturing and also very close to the engineers. So the 370 was our first one, and we put that actually upstairs with the engineers who were designing so they would understand the capabilities of the process, start to build it in their design thinking. The F900, we've used for the production parts on the airplane, and having that capability right in-house is super valuable for us.
Our FDM technology is perfect because it's versatile, and you can address many different applications that are unique for aerospace.
So if you're going to enable a lot more travel, and if you do that by making flights that are faster and more affordable and more convenient, people are going to travel more often. So you have to make not a little bit of progress in sustainability, but a lot. And from a design perspective, the ability to iterate faster through digital design and 3D printing lets us come up with designs that are fundamentally more efficient.
This is a great example of what we are calling in Stratasys mindful manufacturing. Why? Because when we are taking the 3D printing industry from prototyping to manufacturing, we have an obligation to make the manufacturing more sustainable versus the traditional system that are being used today.
Stratasys and Boom have been partners long before we started to build the first airplane, because we had a shared vision of how digital design and digital manufacturing could help us deliver more speed into the hands of passengers faster and more efficiently.
Şüphe baskı teknolojilerinin fonksiyonel parça üretiminde profesyonel amaçlar için en yaygın kullanıldığı alanlardan biri biyomedikal sektörüdür. Biyomedikal cihazlar genellikle hastaya özel olarak tasarlanan, geleneksel imalat yöntemleri ile üretilmesi zor ve serbest formlu geometrik özelliklere sahip parçalardan oluşur. Bu tasarım özellikleri biyomedikal cihazların üretiminde 3B baskı teknolojilerinin kullanımını oldukça elverişli kılmaktadır.
The human body is a marvelous creation. Every person's anatomy is unique to them. That's why understanding patient-specific anatomy with biomechanical precision is essential for healthcare professionals across the globe. Welcome to Lifelike Digital Anatomy Printing by Stratasys. 3D printing technology, software, and materials combine to create models that replicate close to the same biomechanical properties as human tissue and bone, giving you the power to create the most lifelike anatomical models available. Academic medical centers, hospitals, and medical device companies can create realistic testing environments and train in settings that are as close as you can get to the real thing. Experience the most consistent, accurate representation of your targeted pathology while suturing, cutting, inserting, and deploying devices. See how the artery moves as internal and external forces are applied with blood vessel material that mimics vessel complexities and degeneration with precision. And study the accurate biomechanical behavior associated with physiological and pathological characteristics. Experience the density properties of human bone. Mimic porous bone structures, fibrotic tissues, and ligaments. Models behave like native bone when force is applied, such as discectomy, drilling, reaming, sawing, and pedicle screw insertion. Even tumors and infected tissues can be added to your bone or organ models in their accurate form, so healthcare professionals can experience the same tactile feedback when performing medical procedures with surgical instruments and devices. Study your patient's anatomy, then plan and execute your approach before ever stepping into an operating room. Reduce the need for cadavers, clean rooms, sterilization of tools, biohazard risk, and other valuable resources. The digital anatomy printer software has a preset anatomy menu with more than 100 options that allow you to print accurate, lifelike models in a few clicks by simply choosing the desired anatomy. Take a step into the world of lifelike anatomical printing.
Bunun yanı sıra 3B tarama verileri ile beraber manyetik rezonans ve bilgisayarlı tomografi ile yapılan taramalar sonucu elde edilen veriler kullanılarak 3B baskı ile üretim yapılabilmesi sektörde bu teknolojiye olan ilgiyi daha da artırmıştır. Günümüzde ortopedik implantlar, protezler, ortezler, diş sağlığı ile ilgili ürünler ve birçok 3B cerrahi enstrüman 3B yazıcılar kullanılarak üretilebilmektedir. Aynı zamanda ilaç sektöründe tablet ve kapsüllerin üretimi de 3B baskı teknolojileri ile yapılabilmektedir. Bunların dışında 3B baskılamanın tıp sektörüyle buluştuğu diğer bir uygulama alanı ise 3B biyobaskıdır. 3B yazıcılar kullanılarak 3 boyutlu, fonksiyonel, yaşayan dokular üretmek mümkün olmaktadır. Bu yazıcılarda genel olarak hidrojel, silikon, protein solüsyonları gibi malzemeler kullanılmaktadır. Bu alanda çalışan araştırmacıların en büyük amaçlarından biri yakın gelecekte fonksiyonel ve nakledilebilir insan organları üretmektir. B baskı teknolojisinin 3 boyutlu, karmaşık geometrili bir modeli doğrudan fiziksel bir objeye dönüştürebilmesi ve serbest formlu objelerin üretimindeki başarısı gıda sektörünün de dikkatini çekmiştir. Sektör çalışanları müşterilerinin istekleri doğrultusunda özel tasarlanan yiyecek ürünlerinin imalatı ve artistik sunumlar için bu teknolojiden faydalanmaktadırlar. O alanda FDM'in yanı sıra SLS, SLA ve PJ eklemeli imalat teknolojileri de kullanılmaktadır.
It's ready to push out the chocolate.
CocoaPress is creating a 3D printer that prints chocolate. It builds up chocolate layer by layer to make any shape that you want.
That's the ghost. Happy Halloween.
I've been doing robotics since 2013. I actually started working on CocoaPress 6 years ago in my senior year of high school. This was the original one that I built in high school. That's where it all started. And if you told me 6 years ago that I would be working on this after graduating college, I would not have believed you. After I graduated, I started a company and actually just launched the printer for pre-orders on October 10th. My mom always said I had the smallest sweet tooth of the family, so I think it's really funny that I'm the one who now works with chocolate all the time.
The melted chocolate here will push down into the nozzle.
Chocolate is just so personal to people. It gets people excited immediately.
That mini fridge looking area is cooled so that the chocolate will solidify faster.
We have white chocolate, milk chocolate, and dark chocolate.
We had a chocolate taste testing with all of us and tried a bunch of different ones. It's a caramel chocolate. It's really good.
These are the chocolate callets that we melt down down and temper. The cartridge refill goes right into the machine, and then the printer allows you to make whatever you want.
This is a pumpkin. This is a white chocolate dyed orange.
The possibilities are endless, which is really nice.
This is called gyroid infill. When you eat it, it dissolves all those thin little layers onto your tongue one at a time. Every time I make one, everyone in the office is like, ooh, I want to try it.
It's exciting to just come up with new designs.
Each of these different compartments could be filled with a different filling. You'll be able to do this by just plugging in an SD card.
Throw it on the printer and it takes care of the rest at that point.
You can set it and just let it go for however long, and you can do all this insane chocolate casting work that would take a lot of time by hand.
Our product is a little bit more focused on like small bakeries or people planning events. You can imagine creating a custom cake topper for a wedding. Instead of putting name cards at everyone's plate, print out their name and put it on their plate. We printed Amy's name. There's not an easy way to do that right now if you walk into a chocolate shop.
Printing could transform the food industry. Edible growth is about 3D printing with living organisms. You print a structure of seeds and spores and yeast, and from there on it will develop in 3 to 5 days to a fully grown edible. As it comes out of the 3D printer, you can really see the straight lines of the technologies, and as it develops you can see the organic shape. So by transforming appearance, you can see the stages of growth and the development of taste and flavor. By 3D printing food, you can make the production chain or the food chain very short. The transport will be less, there is less land needed, but it's also you can experiment with new structures. So you can surprise the consumer with new food and things which hasn't been done before. I think it will take at least 8 to 10 years before this can be on the market, because they really have to develop the technologies much further. A lot of people think if products are produced by industrialized production methods, it's unnatural or unhealthy. And I want to show that it doesn't have to be the case, because you can really see that it's natural and it doesn't contain any preservatives, because it doesn't need to be stored or anything. So it will contain everything you need inside, so it's actually really healthy and sustainable also.
Akademik çalışmalarda ve patent sürecinde prototip modellerin üretiminde yoğun bir şekilde kullanılan 3B baskı teknolojilerinden hem üniversitelerde hem de ilk ve orta öğretim eğitim kurumlarında proje tabanlı öğrenim, tasarım odaklı düşünme ve analitik düşünme becerilerinin geliştirilmesi gibi konularda eğitim ve öğretim alanında da faydalanılmaktadır.